pen with exponents really mean, what exponents really mean. So let's see if we can get the pen to work here. There we go. So let me change colors. No, alright, go back here. Okay. Exponents really mean repeated multiplication. So whenever you see 2 to the 5th power, it really means 2 times 2 times 2 times 2 times 2. Okay? So we're going to do these problems without the calculator. So 5 times 5 times 5, that would be 25 times 5, and 25 times 5 is 125. So that would be our answer for number 1. For number 2, we would have 3 times 3 times 3 times 3. So 3 times 3 is 9, and this 3 times 3 is also 9. 9 times 9 is 81. Okay? Be careful when you have negatives. Negative 2 to the 3rd power here. That negative is not inside of the parentheses. This is going to be negative 2 times 2 times 2. Only the 2 is repeated, not the negative. This is going to give you negative 4 times 2, which is going to give you negative 8. With number 4, you've got negative 4 times 4 times 4. And so 4 times 4 is 16. 16 times 4 is going to be 64. So you'll get negative 64 for that one. Okay. Whenever you see a problem like number 5, you've got a negative that is cubed, and it's inside of the parentheses. So this means negative 5 times negative 5 times negative 5. And negative 5 times negative 5 is 25, positive 25 times negative 5. And that's going to be negative 125. Okay. 6, this is 3 squared, so 3 times 3 times 2 to the 3rd. 2 times 2 times 2. So 3 squared is 9, and 2 times 2 times 2 is going to give you 8, and 9 times 8 is 72. Okay. For this one, let's use a little shortcut here. We've got 3 times 3 times 3 times 3 times 3. So this would be 3 to the 5th power. Now we already did 3 to the 4th power. It was 81. So 81 times 3 would be 3 times 8 times 3 is 24. So 243 for that one. For number 8, you would have negative 4 times negative 4 times negative 4 times negative 2 times negative 2 times negative 2. And so we did negative 4 to the 3rd power. We got negative 64, although the negative was on the outside here, but it would still be negative. So we'll get negative 64 times negative 2 times negative 2 times negative 2 is going to be negative 8. And if we do 64 times 8, 8 times 4 is 32, carry your 3, 48, 49, 50, 51. So we would get positive 512 for number 8. For number 9, we would have 2 times 2 times negative 10 times negative 2 times negative 2. So 2 times 2 is 4 times negative 10 times negative 2 times negative 2 is positive 4. So this is going to be negative 40 times 4, and that will give us negative 160. Okay. The last one throws people off a lot, but when you have 2/3 to the 3rd, that's 2/3 times 2/3 times 2/3. And so 2 times 2 times 2 is going to give you 8 in the numerator. And 3 times 3 times 3, that's going to be 3 times 3 is 9. And then 9 times 3 is 27, so you get 9 over 27. You're really just cubing the top number and cubing the bottom number. Okay, so these have all been worked out with numbers. Let's move on to doing the same thing with exponents and variables. So those have exponents. These have variables and exponents. So when I have x squared times x to the 4th, that is x times x, that's x squared, times x to the fourth, so 4x. So when I do that, I've got 6x's multiplied together, so I could write that as x to the 6th. Notice what we did here. We have 2 plus 4 would give us 6. We add our exponents. Okay? If I have x squared to the 5th, then that means x squared times x squared times x squared times x squared times x squared, which would be x to the 10th if I add all those 2's together. That's also 2 times 5, so we can multiply exponents whenever we have a power to a power. Okay, and last, quotients of powers. When we have x to the 4th, we've got 4 x's on top, and we only have 1 on bottom, so that one set is going to cancel out. That leaves us with x to the 3rd on the top. In this case, this x right here does not have an exponent, but it's got a little invisible 1 there, so we could subtract 4 minus 1, so we could subtract our exponents here. Okay, so let's look at these problems. For 11, a to the 5th times a to the 7th, you're multiplying like we did up here, so we'll just add those exponents and you get a to the 12th. 12, we've got 27, 3, and 5. We're going to add all those exponents, and when we do, we get b to the 35th. Okay, here we have a power raised to a power like we had right here, so we need to multiply our exponents for this one. So this problem is going to be x to the 30th power. Alright, for 14, we have a coefficient. And so when we have that coefficient, what we've got here is we've got 3x squared times 3x squared times 3x squared times 3x squared. Now, I don't want you to have to write that out every time, but you see we've got 1, 2, 3, 4 3's that are multiplied together. So what we're doing here essentially is we're doing 3 to the 4th power, and we're doing x squared to the 4th power. And 3 to the 4th power is going to be 81, and x squared to the 4th, that is x to the 8th power. We multiply that 2 times 4 right there. When we have a fraction like this, you got a couple options. You could multiply your exponents first, or you could reduce first. In this case, I think I'm going to reduce first. I've got 5 x's on the top and only 2 on bottom, so if I subtract those, 5 minus 2 gives me 3, so that gives me x to the 3rd to the 4th power, and x to the 3rd to the 4th power would be x to the 12th. Okay, for 16, I've got x to the 3n to the 5th power, so this is a little strange with that n right there, but this is still a power to a power, so we just multiply our exponents. So that is going to give us x to the 15n. Okay, 3n times 5 would just give us 15n. For 17, I can't do like I did on number 15 and reduce because I have an a on top and a b on bottom. I'm just going to raise both of these to the 3rd power, and that's going to give me a to the 21 over b to the 9th power. Okay, for 18, this is a power to a power. I have to make sure I raise both of these to the 4th power. So I'll get a to the 16th, b to the 20th for that. Okay. For 19, I'm just multiplying. So I'm going to multiply all my coefficients, 2, 5, and 6. And that is going to 2 times 5 is 10, so I'll get 60 when I multiply those together. Then remember that this a right here doesn't have an exponent, but if it's not written, it's got a little invisible 1 right there. Same thing for this b right here. So if I put my a's together, I've got 1a here and 2 a's here, so that'll be a to the 3rd. Then I've got 3 b's, another b here, and 4 b's here, and that's going to give me b to the 8th. Okay, for number 20, we're going to take our coefficients and we're going to reduce them. So I could divide both of these by 2. I'd get negative 2 on top and 3 on bottom. For my m's, I've got 30 and 12, so I'm going to subtract those. And that is, so I'm going to go ahead and put over here 2 over 3. That is going to give me m to the 18th on top. The ends are going to cancel each other out because I've got one on top and bottom. And then I'm going to have p to the 15th over p to the 10th, which is going to give me p to the 5th. You may see this written like this, or it might be written like this, negative 2/3 m to the 18th, p to the 5th. Okay. For number 21, you have to do this power here before you can combine these two. So if you do this power, you're going to get the first parenthesis stays the same, x squared y to the 3rd over 4xy times x to the 4th over y squared. Remember, you got an invisible 1 here, so 1 times 2 gives you 2. Then you can combine your x's in the top and your y's in the bottom. So that's going to give you x to the 6th, y to the 3rd over 4xy to the 3rd. There I'm just adding together 2 and 4 gives me the 6 here. Y, that has a 1, and y squared gives me y to the 3rd. Now, I have x's and y's, so I can reduce a little here. Notice my y to the 3rds match exactly, so they will cancel each other out. Y to the 3rd divided by y to the 3rd equals 1. Here I've got 6 x's on top, and I've got 1 on bottom, so I could subtract there, and I'll get x to the 5th. And then the only thing I've got left on the bottom would be a 4. That would be my answer for that one. For 22, I'm going to multiply my coefficients. So negative 1 times negative 2 times 3 is going to give me a positive 6. If I look at my a's, I've got 2 a's here and 2 more a's here, so I'd get a to the 4th. For my b's, I've got 1 b here and another b here, so I'd get b squared. And for the c's, I've got c to the 3rd, 1 c here, so that's going to be c to the 4th. And that would be my answer. Okay. 23 is really tricky. You've got the same bases. So right here, this is like a problem like number 11. You've got the same base, you add the exponent. So that means we're going to have y to the 2n plus 4n plus 1. 2n and 4n can be put together, so that's going to be y to the 6n plus 1. Okay. For 24, I've got the same base for the first two, but I don't have the same base for the last problem. So what I'm going to have to do here is keep these separate. So I can put these two together and call it 3 to the x plus y. I can add those exponents, but I still have to have the 4 to the x over to the end because those cannot be combined.